Hello friends, I am Sarvesh Sonkar, TA for this course, Aircraft Design. Today I will discuss about the problem of weight fraction. In this problem, we have an civilian aircraft with velocity 0.6 Mach number and aircraft carrying total equipment and payload 10,000 pound and 4 crew member of 800 pound. We have to calculate weight fraction Wf by W naught, and for this calculation speed of sound is 994.8 feet per second. As shown in the figure, this is your mission profile. Aircraft loiter between point 3 and 4 for 30 minutes and point 5 and 6 for 40 minutes and point 11 and 12 for 20 minutes. So same problem, only mission profile has been changed in this example. So first I will read the data for the of the different types of engines. So here the SFC, for pure turbojet, for low bypass turbofan, high bypass turbofan, for cruise, for loiter, point 9, point 8, point 8, point 7, point 5, point 4, and SFC for different weight fraction. So warm up and takeoff, climb and landing. So for warm up and takeoff, 0.970, point 995, and the mission is loiter, again loiter, so for this mission, this one is warm up and takeoff, climb, and this is cruise, range of this is 0.3, that is in feet, and there is a loiter loiter for 30 minutes. Suppose I am taking 30 minutes. Again, the range of this cruise, that is 2070866 feet. Again loiter, for 40 minutes. Point 5 and 6 is cruise. At the same range, 1035433 feet. And here suppose there is a emergency landing. So here again we will take warm up and take off. And this is landing, 0.8, 0.9 and 10. Again climb and cruise at 1035433 feet and loiter is 0.10 and 11, 12, 13, 14. So here again cruise at same range, that is 1035433 feet, and this is landing. So now this is a different type of mission, and we will start the calculation of weight fraction between different points. So first we will use the historical data. So W1 by W0 is warm up and takeoff, that is 0.970. Second, for the climb, W2, W1, that is 0.985. Third one is W3 by W2. So this is cruise. So in this mission, our aircraft is same as the previous one, that is pure turbojet engine. So for cruise condition, we will use the historical data, that is 0.9. So first we will convert into second, so that is 0.000 per second. So for cruise condition, RC V into L by D max, L by D not max. So put the value of R, that is range, 1035433 feet into this value C, SFC, specific fuel consumption, into velocity 596.88 into 13.9, L by D 0.866 into L by D max. As the previous one, the L by D max range is 16,
So that is 13.9. So basically the range of L by D is between the 16 to 20. So here for this problem I am taking 16. So L by D is 13.9. Okay. So that is e raised to the power 258.85825 divided by 8296,632. Please check it. And the W3 by W2 is 0.969. So W3 by W2 is 0.969. Again, we need to find the ratio of W4 by W3, the weight fraction of W4 by W3, that is in loiter case. So for loiter, EC divided by L by D max, so that is E. So for E, you need to convert into second, 30 into 60, 1800 second. So put 1800 into C. For pure turbojet engine, in loiter case, the C is 0.8. So we need to convert it 0.8, that is in per hour. So 0.8 double 3600, and this will give the 0.02222 per second. Okay. So put here 0.222 divided by the L by D max value is 16. So here e to the power minus 0.3996 divided by 16. So value is e to the power minus, please check the calculation, 9975. So value is 0.975. So W4 by W3 is 0.975. So I will erase it, and so weight fraction between 0.5 to 0.4, again same as cruise, and same formula we will use, that is RC divided by E into L by D, that is e raised to the power, R is 2070866 into C 0.00025 divided by 596.88 into 13.9. This is e to the power 0.0624, that is 0.939. So W5 by W4 is 0.939. So 0.939. So again for 0.5 to 6, the weight fraction between 0.5 to 6 is loiter for 40 minutes. So E for this case, so So this is suppose even, so 40 minutes into 60, 2400 .000222 divided by L by D max 16. So again W6 by W5 is e to the power minus 0.03333, that is 0.967. So I will write here point W6 by W5 is 0.967. So again for this cruise condition, this range and this range is same, so ratio is also same. So ratio will be W5 by W6, sorry, W7 by W6 is 0.969, and for 0.7 to 8, so W8 by W7. For landing, we will use the historical data, that is 0.995, so that is 0.995. Again here I am taking this condition warm up and takeoff, so using the historical data, W9 by W8 for warm up and takeoff 970, and for again 0.9 to 10, that is climb. So for climb is 0.985, 0.985. So here for 0.10 to 11, the range is same as 0.2 to 3 and 0.6 to 7. So weight ratio, weight fraction will be same. So here W11 by W10 same as W3 by W2 or W7 by W6. So W7 by W6 is what? 969. Again the loiter, so W12 by W11, so loiter for 20 minutes. So again you have to convert it e to 20 into 60, that is 1200 second. So for loiter, EC divided by L by D, so e to the power, E is 1200 second, 1200 second, into C for the loiter case 0.2222. The L by D value, so this is max value, so L by D max value is 16. So W12 by W1 is 0.983. Please check this value. So this will be e to the power minus 0.016665. So it will 0.983. So again for 0.12 to 13, so W13 by W12, again range is same, as you see 1035433 is equals to the and this path value and this path value also. So weight fraction will be also same. So it will be 0.969, and again use the historical data. So here historical data is for landing 0.995. So 14 divided by 13.995. Okay, we need to find the Wf by W naught. So Wf is equals to final weight is equals to initial minus final, that is 14. So Wf by W naught is 1 by W14 by W naught into 6% fuel trapped. So find the value of W14 by W naught. So W14 by W naught is equals to W1 by W naught into W2 by W1 into W3 by W2 into W4 by W3 into W5 by W4, W6 by W5, W7 by W6, W8 by W7, W9 by W8, W10 by W9, W11 by W10, W12 by W11, W13 by W12, W14 by W13. Put all the weight fraction into this equation and find the value of W14 by W naught. So value is corresponding this weight fraction. This is equals to, एक बार इसको चेक करिएगा, and again put the W14 by W naught value into this equation. So find Wf by W naught, 1 minus 0.693 into 6% fuel trapped fuel, so multiplied by 1.06. So this is 0.325. So this is the Wf by W naught. So please check all the calculation part and make it correct if there is any mistakes. Thank you.